Good to be with you. Welcome to Class Outside. Today, we're going to learn how to call APIs with self-signed certificates in Unity by using a custom certificate handler. To demonstrate, I will be using Unity version 2022. We will need Node Package Manager, npm, and Node.js to help set up and run our project. We will also need the openssl software to support HTTPS on our local network, and I will use this project on GitHub, which includes an example backend service and the C# files for Unity. I will also use the code editor Visual Studio Code to view and edit this project. Specific versions used, other tutorials mentioned, and download links are available in the video description. After installing Unity, npm, openssl, and Visual Studio Code, we can download the demonstration project from GitHub. Let's find the downloaded zip folder and extract it. This project has two folders, one which contains the backend, and another which contains the C# files for Unity. Then open VS Code and navigate to the backend service folder. VS Code often asks if you trust the authors for most newly opened projects. To continue, click Yes. Open a new terminal from the top menu. The terminal should appear in the bottom panel. We want to make sure the terminal is pointed at the folder with the file named package.json. Then, run the command npm install. This command will read the package.json file and install any libraries required by the project. Then, let's use the cd command to change directory to the keys folder, and use openssl to set up the key and certificate needed for HTTPS. The command for this and other steps can be found in the video description. This command generates the key and certificate required to use HTTPS. You will be asked some questions in the terminal for this certificate, like the location and name for who this certificate is for. Since this is only meant to run on our local network, we can put anything or just empty spaces for all of these fields. Once created, use the cd command with two dots to move up a folder. This should bring us to the base directory of our project, and run the command node server.js to start the backend service. Now, let's prepare a Unity project. I will demonstrate by opening Unity Hub and starting a new project using this 3D template. I will name the project and disable Unity Cloud Connection. With the project loaded, let's add a new empty game object. I will name it call local API. Let's open File Explorer to the other folder that came in our GitHub download. In the C# files folder, we should see a file named call backend service example. Click and drag this file into the asset folder of the Unity project. Now with the call local address game object selected in the hierarchy panel, we can click and drag the C# file to the inspector panel on the right and add it to the object. The C# script reveals the URL to be called in the inspector. We need to replace part of this URL with our local IP address and the port our backend is running on. To find our port number, we can reopen Visual Studio Code and see what is printed in the terminal. In the demonstration project, we can see that the port is 3001. To find our local IP, we can run a command in the terminal. On the top right of that terminal panel, there should be a plus button with an arrow next to it. Click the arrow and choose to create a new command prompt window. You can then run this command I left in the description. This will retrieve IP address information related to your machine. I recommend trying the first address that appears. If you have multiple, you may need to try each one to see which is successful. In Unity, let's delete the replace text and replace it with the IP address, then a colon, and then our port number we got from VS Code. Let's review the C# file to see how this works. I will open it in Visual Studio Code. In the method getJSON from API, we can see the Unity web request is created. And here we see that we update the request certificate handler with an object called bypass certificate. We create this object in the code below. This object inherits from the certificate handler class, which means we can use it to replace the default certificate handler. And we see that we override the valid certificate method, which runs when attempting to call an API. Here we always return true, accepting the certificate as valid, and this is how we permit self-signed certificates. This should be removed before using this code in a production setting, or in any place where the project is run on the internet. Using this outside of a local, trusted network may lead to severe security risks. For now, if we're on a trusted local network, and only using this for development, we should be okay. Back in Unity, let's open the console in the bottom panel and click play. If everything worked, we should see a hello world message on the console. Look at that. Together, we have called an API with a self-signed certificate in Unity. Please let me know down in the comments what you thought of this video. Have a great day, and thank you for attending Class Outside.